We also have some properties of integer multiplication. These are quite in line with the properties we learned about whole number multiplication. So we have the closure property of the multiplication of integers. So that means that a times b gives us another integer, and that's a unique integer. Commutative property of multiplication tells us that if we have two integers a times b, that is equal to b times a. And then the associative property tells us that we can group, when we're multiplying three integers, we can multiply a times b first and then multiply times c, or we could multiply b times c first and then multiply with a, so it's associative. We have an identity property, so 1 is our unique multiplicative identity in the integers, and that tells us that for any integer a, 1 times a gives us a back, or a times 1 also gives us a back. Then finally, with the integers, we still have the distributive property. So a times b plus c will leave us with a b plus ac, and we could also go the other direction. If we have addition first, we can distribute a to b and a to c, and we get the same result. And then we have the zero multiplication property. So anything multiplied times 0 gives us 0 itself. So for any integers a, b, and c, we also have to think about what happens when we have negatives. So the interesting part is that if we have a negative integer, or the negation of an integer, that's just the same as if we took -1 times the integer that's not being negated. Then negative a times b is the same thing as b times negative a because of the commutative property, but then we can also think about this as negative a times b. And then if we have the negation of a times the negation of b, then that result is just the multiplication of a and b. You've probably heard the phrase that two negatives would cancel each other out. And then we can use that distributive property of multiplication over subtraction in the integers. So we can distribute a to b and then a to c when we have subtracting b minus c, and we're left with ab minus ac. And the same goes for distributing to the left. So let's think about some examples. We can simplify expressions so that there are no parentheses in the answer. So if we think about -3 times x minus 2, then the first thing you might do is distribute -3 to x and -2. So if we distribute -3 to x and -3 to subtracting 2, then I would have, by that distributive property of the integers over subtraction, I get -3 times x minus -3 times 2. -3x, and then I multiply -3 and +2 together to get -6. And I'm left with -3x plus 6, because when I subtract a negative integer or a negative value, I am adding the positive of that value. So -3 times x plus 6 is our final result. Okay, so here's another example. If we have x plus 4 multiplied by x minus 4, so we might start by first distributing x plus 4 as one unit across the subtraction of x minus 4. So if we did that, then we would have x plus 4 times x minus x plus 4 times 4. So we keep the subtraction and we are distributing x plus 4 across the subtraction. Then we might distribute to the left our x and our 4 across that addition. Now the important thing to notice here is that we're subtracting all of x minus 4 times 4. So we're going to need to keep that subtraction for everything that we do in this multiplication of x plus 4 times 4? So we would distribute x to x, and we get x squared. X times 4 is 4x. And then we subtract all of 4 times x, or 4x, and 4 times 4, so plus 16. So we subtract that entire expression. Then finally, we can think about how subtracting is the same thing as adding the negation of that expression, and then we can distribute the negation across the addition. So if we distribute a negative to 4x and a negative to 16, we result in the same x squared plus 4x plus negative 4x plus negative 16 when we distribute that negative across. And then we can see and recall adding 4x plus negative 4x, those two things are inverses of each other, so they would cancel. And we have x squared minus 16 as our result. And this is actually called the difference of squares formula. You'll notice that 4 squared is 16, and we have x squared minus 16. So the difference of two square values, because this is really, we could think about this as x squared minus 4 squared. So the general theme for this is if we have integers a and b, and we have a plus b times a minus b, the result is simply a squared minus b squared. All right, so let's try using the difference of squares formula to simplify these expressions. We start out with 4 plus b times 4 minus b. So knowing that this is a difference of squares because we have an integer plus an integer times an integer minus that integer. So using that difference of squares, we see that we will result in just 4 squared minus b squared, and we could continue to simplify and calculate 4 squared as 16. Now if instead I had negative 4 plus b times negative 4 minus b, I would then get negative 4 squared plus, or excuse me, minus b squared. But negative 4 squared is just the same thing as 4 squared, because we would have the negative times the negative. Negative 4 times negative 4 is positive 16. So we're left with the same result, actually.